mechanics. So there are different branches in civil engineering like construction, environmental, geotechnical, material, structural, transportation, and urban planning. So the soil mechanics is the branch of civil engineering that uses the principles of mechanics, hydraulics, and to some extent chemistry to solve the engineering problems related to soil. It is a branch of civil engineering which deals with the study of characteristics, classification, and behavior of soil under loaded and unloaded conditions. Soil mechanics helps an engineer to know theoretically or experimentally the behavior of soil under the action of loads, gravitational forces, water, and temperature. Simply speaking, it is a knowledge of engineering science which deals with properties, behavior, and performance of soil as a construction material or foundation support. Almost all the civil engineering structures like buildings, towers, bridges, etc. are found on soil. All these structures are very heavy as they are made up of heavy structural elements like concrete, earth, brick, wood, and steel. And all this load is supported by the soil below, the ultimate foundation. Soil in its natural and undisturbed state is very inhomogeneous or anisotropic, which means it is non-uniform and diverse everywhere at any depth. Soil exhibits a wide range of behavior even when the conditions are slightly different. The term soil mechanics was coined by Dr. Carl Kawasaki, who is also known as the father of soil mechanics. Soil mechanics is the application of the laws of mechanics and hydraulics to engineering problems dealing with sediments and other unconsolidated accumulations of solid particles produced by the mechanical and chemical disintegration of rock, regardless of whether or not they contains an admixture of organic constituents. Soil mechanics is therefore a branch of mechanics which deals with the action of forces on soil and with the flow of water in soil. Why we need to study soil mechanics? Various reasons to study the properties of soil mechanics includes foundation to support structures and embankments in which it is subjected to static loading and then it is subjected to dynamic loading. So second is we can use it as a construction material. So for subgrade of highway pavement, for land reclamation, and for earth and dam. The third one for slopes and landslides. So slopes and landslides occurs or failure of slopes and landslides occurs due to the reduction in shear strength, increase in moisture content, and increase in unit weight. So the fourth one is the earth retaining structures. Earth retaining structures are constructed to retain any material and prevents it from sliding or eroding away. So these are the various figures of such structures. There are miscellaneous applications as well, which includes the effect of river water on soil mass, effects of frost action on soil mass, and land erosion, settlement of structure in summer, heaving during winter due to the formation of ice. So, moving to the formation of soils, it can either be formed by physical weathering or chemical weathering. So, weathering is the breaking down of rocks by physical and chemical process into smaller particles. So, there are two main types of weathering. The first one is physical, or we can say mechanical weathering. The second one is this chemical weathering. So, physical or mechanical weathering is the disintegration of rocks into smaller particles through physical processes, including the erosion of water, ice, and wind, opening of cracks as a result of unloading due to erosion of overlying soil and rock, loosening through the percolation and subsequent freezing of water, thermal expansion, contraction from day to day and season to season, landslides and rockfalls, oppression from downhill movement of nearby rock and soil. So moving to chemical weathering, it's the disintegration of rock through chemical reactions such as hydration, carbonation, oxidation, solution, and hydrolysis. So this is the weathering cycle in which igneous rocks, metamorphic rock, and sedimentary rock, due to its disintegration or uplift and exposure, it weathers, and then weathering occurs and it transported and deposited and lithification occurs, and again this process continues. So this is a simple figure in which it explains how this weathering occurs. So moving to the transportation of soil, there are different ways in which soil can be transported. The first one is this water transported soil. So if it is by lake, we can call it as lacustrine deposit, by sea marine, and it is by river, we can call it as alluvial deposit. So wind transported soil is also called this aeolian soil, and glacier deposited soil is called drift or till. That is it. Thank you.